So our next problem is this one. Like if x to the power y equals to e to the power x minus y, then we have to prove dy dx equals to log x divided by log ex whole square. Okay. If you can remember, I have told in few of my differentiation videos that if we get this kind of expression like any function to the power another function, then in almost every of these types of cases we will apply log on both the sides. Okay, so if we apply log on both the sides, then we will get y log x and x minus y log e. As we know, by default the base of the log is e. So if we assume the base as e, so log e to the base e will be equals to 1. Okay, so y log x would be equals to x minus y. Now take the y at either of the sides, either left side or right side. I am taking out this y at this side. So we will get y in the bracket 1 plus log x equals to x. And like can we write y equals to x by 1 plus log x. Sorry. So as you can see, we can now apply the formula of u by v, as this is one function, algebraic function, and this is one function, logarithmic function. So if we apply the formula of ddx of u by v, we will be able to get the value of dy dx, and we need to prove this one also. Okay. So now differentiating both the sides, what we'll get? We'll get dy dx equals to v square, which is 1 plus log x whole square, v as constant, derivative of x is 1 minus x constant, derivative of 1 plus log x would be 1 by x only. Why? Because derivative of log x is 1 by x and derivative of 1 is 0. So ultimately the derivative of 1 plus log x will be 1 by x only. Right? Now if we cancel out x and x, we have 1, we have minus 1, and from here we are getting plus 1, 1 plus log x minus 1 ultimately. So if it is 1 plus log x minus 1 divided by 1 plus log x, see, we can easily cancel out plus 1 and minus 1. Okay, so what is remaining, like in the numerator it is log x, and as we have to prove in this form for the answer, we can keep this denominator like 1 plus log x, but as we need to prove the denominator as log ex whole square, so can we write the 1 as log e, and I'm keeping the log x as it is. Okay, so can we write like log x divided by, as we know that log a plus log b equals to log a into b, right? Sorry, this will be whole square. So log a plus log b will be log a into b, so it will be log e into x and whole square at the power. So as you can see, we have proved that dy dx equals to log x divided by log ex whole square. Okay, so I hope you have understood this solution. It's not a hard one, just you need to separate the y from the x variables like I did. Okay, and then just you need to apply the formula of ddx of u by v. Then it is totally process oriented, nothing much to do here. Okay, so although if you have any kind of problem, as always I say, you can pause the video and follow step by step, or later reach out to me for any kind of concern. Okay, so let's move on to the next problem. So in our next problem, we have, if sin y equals to x into sin a plus y, then we need to prove that dy dx equals to sin square a plus y divided by sin a. Okay. So, as you can see that from the given expression, at both the sides we have sin, like sin y and sin a plus y. So you can easily see that there is no scope to separate y variable. We have a scope to separate the x variable only. Okay. So can't we do like this way, that we need to find dy dx, but we can find dx dy, like I am asking you to find dx dy first, then whatever be the answer, we can say that it is 1 by dy dx. Same thing. So instead of finding dy dx directly for this problem, we will solve like dx dy first. Like till now, almost for every problems, I guess, I have been solving the differentiation in terms of x, I mean with respect to x. But for this problem, we will differentiate in terms of y. Okay, just show, just see, I mean. Okay, so from the given equation we can write x equals to sin y divided by sin a plus y. The formula will be same. We can assume it as u function, we can assume the denominator as v function, like we did till now for all of this kind of problems. Okay, so just the difference is we need to differentiate both the sides with respect to y, not x. Okay, so if we differentiate x with respect to y, then it will be dx dy. If we would have differentiate x with respect to x, then it would have dx dx. That means 1. As we are differentiating x with respect to y, that is why we have written dx dy, right? And likewise same, in the denominator we need to do the whole square of the v part. In the numerator it will be sin a plus y into d dy of sin y. I hope you can understand why I have written d dy, as we are differentiating with respect to x. Okay, minus sin y constant d dy of sin a plus y. Okay, now so sin a plus y, we can write d dy of sin y would be cos y. Okay, but we will not write any kind of dy dx, you know, because we are differentiating in terms of y now. Just imagine if it is d dx of sin x, then you would have written cos x only. Just similarly, d dy of sin y, I have written cos y. Okay, minus sin y and d dx of sin a plus y would be cos a plus y. Now, if you have done a bit of trigonometry in your secondary or higher secondary standard, then one formula you should remember. Like, you know the formula, like sin a cos b minus cos a sin b. Suppose you assume this as x, you assume this as m and y as b. You assume a plus y as m and y as n. So sin m cos n minus cos n sin n. What is this formula? So now if we apply this formula here, so you can compare that it is sin a cos b minus cos a sin b, right? So it is sin a cos b minus cos a sin b. So we can apply this formula. So what is my capital A angle? Is a plus y, and what is my B angle? Is y. So can I write this as sin a plus y minus y divided by sine square a plus y. So we can easily cancel out y plus y and minus y. Okay, so we have sine a divided by sine square a plus y. So we have sine a divided by sine square a plus y. Okay, so this is the value of dx dy. You remember, this is the value of dx dy, what? Sine a divided by sine square a plus y. As I have told in the beginning that if we need to find the dy dx, we have to reciprocate this answer. Okay, so dy dx would be equals to sine square a plus y divided by sine a, because the numerator will be the denominator and the denominator will be the numerator, as we are making dy dx from dx dy. So this is the value of dx dy. So the value of dy dx would be the reciprocal of it. So that we can prove whatever it is asked to. Okay. So dy dx equals to sine square a plus y divided by sine a. I hope you have understood, but to easily solve this problem, as you know, you need to remember this formula. In trigonometry, you will get this formula. This is the very basic formula of trigonometry. Just you can see that along with sine a minus b, there are formulas like sine a plus b, cos a plus b, and cos a minus b. Okay, you should remember all these kinds of formula because it would help you to solve the problem more faster. Because the formula, the more formula you can remember, the more faster you can proceed with the problem. The more faster you can think by looking at the problem. So you have to remember formula. Not in trigonometry only, not in differentiation only. In whatever be the topics in mathematics, as more as formula you can remember, the chances of picking up a problem will be much faster. You will be able to solve maths in very easier way, in very faster way. Trust me. Okay. So I hope you have understood this problem, how we have proceed with the problem. Although if you have any kind of issues to understand in any of the steps, why I have differentiated in terms of why I have reciprocated the ultimate answer. Okay, like I think it is easy to be understandable, but if you find it difficult, you can always reach out to me, or you can, as I always say in almost every of my videos, that you can pause the video and see the step-by-step solution so that you get the idea. And how we have applied this formula to this one, you need to understand that also. You can, okay? So in our next problem, we have if y equals to 1 plus sin x minus cos x divided by 1 plus sin x plus cos x, then we have to prove that dy dx equals to 1 divided by 1 plus cos x. Okay, so we need to reach up to this point by starting from this point. Okay, now as you can see, there is 1 plus sin x minus cos x divided by 1 plus sin x plus cos x. So we need to try to simplify this form. Okay, so what can be done? And to do anything, you need to remember the formula of trigonometry that I am telling you again and again in few of my videos in differentiation, because to solve various problems of differentiation, you need to remember few of the formulas from trigonometry. It will definitely help you to solve the problem in 3 to 4 steps. Otherwise, you have to stress the problem very long. Trust me. Because if you apply the ddx of u by v to this problem, it will take your time. It will take you 10 to 15 minutes of time. But if we apply the basic trigonometry formula, you see how fast we can do the problem. See with me. Okay. Like, can I write it as 1 minus cos x plus sin x? You would be able to understand why I am bringing the cos x with 1 and separating the sin x. because we know 1 minus cos x equals to 2 sin square x by 2. Just remember this formula. This is pure formula and nothing else. And we can write the sin x as 2 sin x by 2 into cos x by 2. As we know, sin 2x equals to 2 sin x into cos x. Okay, so we will apply almost similar formula. 1 plus cos x means 2 cos square x by 2, and for sin x we are writing 2 sin x by 2 into cos x by 2. Okay, just follow step by step and just see what the formula I am asking you to remember. Like for 1 minus cos x, like 1 minus cos 2x, the formula is 2 sin square x, and 1 plus cos 2x, the formula is 2 cos square x. Okay, so just check if any common we can take. So you can see we can take from the numerator 2 sin x by 2 as common. So what will be left? Sin x by 2 plus cos x by 2, right? And in the denominator we can take 2 cos x by 2 as common. So what will be left? Cos x by 2 plus sin x by 2, right? So from both the numerator and denominator we can cancel out sin x by 2 plus cos x by 2 and sin x by 2 plus cos x by 2. We can also cancel out 2 and 2. So ultimately this will become tan x by 2. Why? Because we have only sin x by 2 divided by cos x by 2. So definitely it would be called tan x by 2. That means y equals to tan x by 2. Okay. So dy dx equals to sec square x by 2. As we know, the ddx of tan x is sec square x and ddx of tan x by 2 is sec square x by 2 into ddx of x by 2, which is half. So it would be half sec square x by 2, and you know that sec is the reciprocal angle of cos. Okay, so can I write 1 by 2 cos square x by 2, and you know that 2 cos square x by 2 means 1 plus cos x, because 2 cos square x means 1 plus cos 2x, so 2 cos square x by 2 would be 1 plus cos x, right? So it would be 1 plus cos x. So we have proved whatever it is asked to. Just follow step by step. Okay, so we'll move on to the next problem. So we have our next problem as if y equals to e to the power t cos t and x equals to e to the power t sin t, then we have to verify that dy dx into dx dy equals to 1. So we know that dy dx into dx dy equals to 1 in every cases, but we need to find at first the dy dx, then we can do the dx dy part, right? Like, so how we can proceed? As you can see, apart from x and y, there is another variable is t. So what we need to do, in fact I have done few problems based on this kind of concept. So in this kind of problems we have to differentiate both y and x, I mean both the sides of y and x with respect to t. Okay, so if we do that, we get dy dt equals to, as it is u into v form, so it is a u function and you can consider it as v function. So similarly it is a u function and you can consider it as v function. So ddx of u into v would be u constant ddx of cos t plus v constant, sorry, this would be d dt as we are differentiating with respect to t. Okay, so d dt of e to the power t. So what we will be getting? D dt of cos t would be minus sin t only. It would be minus e to the power t sin t plus ddt of e to the power t would be e to the power t. As we know, ddx of e to the power x equals to e to the power x. So ddt of e to the power t would be e to the power t, right? So it would be e to the power t cos t. So we have e to the power t within bracket cos t minus sin t. So similarly, by applying the same concept, if we find dx dt, we will get from this that e to the power t constant, derivative of sin t would be cos t plus sin t would be constant, and derivative of e to the power t with respect to t would be e to the power t. So we will be getting e to the power t within bracket sin t plus cos t, right? So now if we do dy dx, like dy dx equals to dy dt divided by dx dt. Okay, so dy dt is e to the power t cos t minus sin t, and dx dt is e to the power t sin t plus cos t. Sin t plus cos t. Okay, we can cancel out e to the power t from both the denominator and numerator. Okay, so the final output of dy dx can be written as cos t minus sin t divided by cos t plus sin t. So as you can see, the dy dx is coming as t form. Okay, so dx dy would be definitely reciprocal to this form. I mean to say cos t plus sin t divided by cos t minus sin t would be the dx dy. But for this problem, we cannot directly write the dx dy as the reciprocal of it, because again from this problem we need to, so we have the value of dx dt and dy dt. So if we do that, dx dy, which is dx dt divided by dy dt, okay, then what it would be? It would be e to the power t sin t plus cos t and divided by e to the power t cos t minus sin t. So similarly, like, so from the denominator and numerator, we have cancelled out e to the power t, and we have, so it can be written as cos t plus sin t divided by cos t minus sin t. So we have the value of dy dx and we have the value of dx dy. Okay, for dy dx, what we did dy dt divided by dx dt, and for dx dy, what we did dx dt divided by dy dt. So definitely the both the answer will be reciprocal of each other. Okay, now if we multiply dy dx into dx dy, so I am just clearing the first part of the problem. I hope you have taken the note, or you can pause the video later to understand also, right? So if we just cancel out this part to solve the rest part of the problem, to get our desired solution. So what we can write now? We can write dy dx into dx dy equals to just this into this one. So cos t minus sin t divided by cos t plus sin t into cos t plus sin t divided by cos t minus sin t. Okay, so as you can see, we can cancel out this part with this one, and we can cancel out this denominator with this numerator. Okay, so we have 1 as the result. So we can easily verify that dy dx into dx dy would definitely be equals to 1. Okay, so how we have started the problem? We have started the problem by applying differentiation with respect to t on both these equations. Okay, thereafter we have shown the result of dy dt and dx dt. Okay, to get the dy dx, we have to do dy dt divided by dx dt, and to get the result of dx dy, we have to do dx dt divided by dy dt. As simple as that. Now you have the value of dy dx and you have the value of dx dy, like this two. So to verify the result, you have to multiply this two result, and if you multiply this two result, you will definitely get 1 always. Okay. So we'll move on to our next problem.